When I talk about mechanistic versus applied research, it's not that one is better or worse than the other. It's that we have to use each type of research for what it's actually intended for. So we should not be using totally mechanistic research with low ecological validity to make claims about very applied outcomes, without having a lot of other research kind of getting us there. At the same time, if we just had no understanding of how something worked in the body, and we were just saying, oh, it seems like if you take this, it makes you stronger. Well, that's not enough. If for us to take that finding seriously, we have to actually understand how and why a particular ingredient is making somebody stronger. And so then we have to work backwards and say, okay, well, now it seems like we're observing this outcome, but we need to figure out why and how this is actually happening.
Hello, my geeslings. It is Mother Goose Robinson Earhart here with the introduction to Robinson's podcast number 72. This is an episode I've been looking forward to for quite some time because it's with one of my idols in the podcasting realm, and that's Eric Trexler, who's co-host with Greg Nuckols of the Stronger by Science podcast. Eric received his PhD in human movement science from the medical school at the University of North Carolina, Chapel Hill. He's not only a professional bodybuilder and sports nutrition researcher, but he's also the co-owner of Stronger by Science with Greg Nuckols, where they have articles, coaching services for training and nutrition, and all sorts of other things, including the podcast that I mentioned, which if you're into strength training, nutrition, it along with another podcast, Iron Culture, those are the two that I go to just for this. And he's also the co-owner of the Mass Research Review, which is a journal, a sports science journal, and the MacroFactor nutrition app, which is a way better version of something like MyFitnessPal. Now, Eric and I in this episode discuss some philosophical concerns in sports science, including methodological limitations in study design and human error in reasoning. So among some other topics, we talk about the ecological validity of mechanistic reasoning. So just for example, what this might mean is if we test something in the proverbial Petri dish, how can we generalize or draw from this implications in the real world? Or how do we go from studies in the real world and then look back and try to determine what mechanisms caused what we have observed? And then we also talk about the ways in which funding and other practical constraints guide research and some ethical considerations that factor into the study of steroids and other performance-enhancing drugs. So there are links in the description. I really, really highly recommend checking out the Stronger by Science podcast. And without any further ado, I hope you guys enjoy this conversation as much as I enjoyed talking with Eric. So you did your PhD at the University of North Carolina, Chapel Hill, and was it in exercise and sports science?
No, because our field likes to make things as complicated as possible. So someone who says I have a PhD in exercise science, it could be exercise science, it could be sports science, it could be kinesiology. In my case, it was human movement science.
Okay.
So that was kind of this broad category. But it was a really cool program. It was pretty interdisciplinary. We had physical therapists there who were studying all sorts of injury rehabilitation. We had a major concussion research center. And then I was over there doing nutrition stuff with a little bit of exercise mixed in. So human movement science, basically, if it involves a human who may or may not be moving, then we covered it.
Okay, nice. So I mentioned before we started, most of my audience at this point is philosophers. So before we get into some of the more philosophically interesting aspects of your domain and research, I'd like to hear a bit about the sort of training an exercise scientist undergoes, or a human movement specialist. Like what's your coursework like that sort of thing?
Yeah. Well, like I said, there's a lot of diversity from program to program. And so, yeah, it is one of those fields where you really need to look in the curriculum to figure out, is this going to be the right thing for me? Uh, to take it all the way back and talk about the origins of the field, one of my undergrad textbook for exercise science had like a history of the field section way at the beginning, like kind of like extraneous content. I think I might be the only person that's ever actually read that part of the textbook. But it's a very fascinating field of study, because if you say, well, when did it start? People, depending on how liberal they are with the definition, they might go back to, basic gas laws. They might go down to fundamental basic research in anatomy, in biology, in chemistry. Exercise science is usually going to be a convergence of things like biomechanics, neuromuscular control, bioenergetics, how the body actually uses sources of energy to complete tasks related to movement. And then obviously all of the biological elements that go into how a body works, how a body recovers, how a body repairs. So the field has a really interesting, it's kind of a convergence of several fields, I should say. And when the field started getting up and running initially, there were really two completely separate tracks. And you can still see the ramifications of that today. So there was one approach to exercise science that basically kind of branched out from physical education, right? So there, you'll see at a lot of universities, the exercise science program is in the School of Education, because it was kind of physical education. Let's rope in some more traditional sciences into that and make it a little bit more physiology focused. And boom, you've got exercise science.
Mm-hmm.
But there was also this completely parallel field forming, or this parallel branch of the field that was actually being kind of, it was kind of sprouting out from physiology programs, from medical programs even. And so it was all these people who were studying human physiology and anatomy and said, well, what about when this machine starts moving? Then what? And then they start bringing in elements that are more focused on movement and exercise. So we see these two parallel fields forming that ultimately kind of converge. And so, like I said, you go to a university, you don't really know where you're going to find the exercise science department. It could be in the School of Education. It could be in the School of Biomedical Sciences. My undergrad was not even a Bachelor of Science. It was a Bachelor of Science in Education. And then my PhD came from the School of Medicine. So long answer, but that's exercise science in a nutshell.
No, that was a really good answer. So you're taking chemistry courses, PE courses, all across the gamut.
Yeah,
as part of the training. And then your dissertation was on the performance effects of citrulline, malate, and beetroot juice supplementation. So most philosophers probably don't know what those things are. What are they? And what did you come up with in your research?
Yeah, so I was really interested in looking at those ingredients. They are ingredients that you can find in a typical human diet, but also have been used in dietary supplement formulations. And they are both precursors to nitric oxide. And nitric oxide, for the longest time, we knew nitric oxide, we knew something existed that was in the body that was inducing vasodilation under certain conditions. And for the longest time, it was being described with this really vague term that roughly translates to, there's something in there that's making blood vessels dilate, but we don't know what it is. And here's what we're going to call it,
Mm-hmm.
And after knowing it was in there doing things, after a lot of research, people realized this is actually nitric oxide, this kind of endothelial relaxation factor that we've been looking at. And up to that point, nitric oxide, we knew it existed for a very long time before we knew it was actually doing stuff in the human body. So we're like, oh, that like atmospheric thing we talk about, nitric oxide, that's actually, in the body doing physiologically meaningful things. And so then, it was like the Time magazine molecule of the year in like 1998, I think. And people said, okay, now we know what this is, and we need to figure out exactly what it's doing. So of course, there's a lot of interest in how it might impact the cardiovascular system, blood flow, blood pressure, things of that nature, any issues related to perfusion of blood throughout tissues. So there was a lot of interest in clinical applications, but then people who exercise were starting to realize these nitric oxide boosters seem to be doing something, or these nitric oxide precursors. And so my research was looking at within the context of exercise, because during exercise, obviously you start exercising, more blood is flowing to the exercising muscle. We'll see that some of the vasculature feeding into that muscle starts to relax to facilitate greater tissue perfusion. So my research was kind of building on prior research where we were looking at, in the context specifically of resistance exercise, are we seeing that these nitric oxide precursors augment or enhance that response to exercise, where we're getting more vasodilation, more tissue perfusion, more blood flow to the muscle that's exercising? And also, is it influencing neuromuscular performance? Because there is, from my view, very compelling research indicating that nitric oxide appears to have a direct impact on actual muscle function. So completely separate from its effects on blood flow, it looks like nitric oxide is directly impacting muscular function and force production. And so that's what my research was looking at. Unfortunately, I set the hypothesis and roll with it. I was expecting that we would see much more pronounced effects of supplementation. Ultimately, we did not. But that is very telling in hindsight. I mean, you always want to have the big splashy finding that confirms what you were expecting to see. But in the case of my dissertation research, we found that it really didn't do much for specifically isometric muscular performance. So where it basically the leg is in a fixed position, or I should say not isometric, isokinetic. So the leg is extending at a fixed speed, basically. So we were doing isokinetic leg extension, where the leg, instead of moving as fast as you can, basically we're locking it in, and the leg can only move so fast. So you're doing as much force as you can at a given speed. We found that supplementation didn't do much for that, but in hindsight, it kind of makes sense, because when we dig back into the literature, nitric oxide seems to be particularly helpful with really explosive muscle actions, very rapid muscle actions. So it's facilitating muscle power more so than muscle strength at a very slow speed. So if we fix muscle actions at a slow speed, we're not seeing that positive effect. But if we let muscles contract at their fastest possible speed, or if we're just looking at a very explosive movement, we do start to see some positive effects. In terms of blood flow and tissue perfusion, again, we didn't find much, but in hindsight always brings so much clarity for researchers. In hindsight, that also makes sense, because we were looking at young, healthy folks who didn't really have tissue perfusion issues or cardiovascular conditions that impair blood flow. And it would be very beneficial to a human being to make sure that it can effectively coordinate that blood flow response during exercise. Exercise was not, in our evolutionary history, always a pursuit of, trying to look good in a bathing suit, or, trying to do better in a particular sport of choice. This is a really critical physiological function that when we begin exercising, we must be able to deliver oxygen and nutrients to the exercising muscle. So it would make sense that for a healthy individual with no impairments to those functions, adding a little bit of extra supplementation into the mix probably shouldn't radically alter the way we deliver blood and nutrients to an exercising muscle. So expected to see all sorts of really fun things, didn't. But in hindsight, I think it helps us contextualize the exciting things that we do see in the literature, which is these things appear to be helpful for people who do have some modest impairments when it comes to cardiovascular regulation of blood flow and tissue perfusion. And we do see some benefits when we look at more explosive tasks, or tasks at which the speed of movement is not artificially constrained.
Now, isn't nitrous oxide also the target then of Viagra? And
one clarification. So there's a big distinction between nitrous oxide and nitric oxide. So that's important, because nitrous oxide, I think, is the stuff you get at the dentist that makes you giggle.
Sorry.
Yeah, but yeah. So nitric oxide, it has similarities in terms of the way that Viagra does work. They are not literally the same thing, but they are acting upon similar pathways to induce vasodilation. So absolutely. And actually, it's funny that you mentioned that, because I do a little bit of work with a supplement company who does have a supplement blend that is intended to facilitate sexual function. And the reason that they reached out to me specifically to provide some consultation is to talk about how can we leverage nitric oxide precursors in a supplement formula in a way that would enhance erectile function, of course, much more modestly than we would see with a pharmaceutical ingredient. But yeah, there is very clear mechanistic overlap there. And nitric oxide precursors, there is some evidence indicating that they do have a modest positive impact in terms of replicating some of those effects.
Okay, good. That means that I'm on the right track, because that's what I was thinking. Since you mentioned that you were working or studying younger individuals, I was wondering if the beetroot juice, the citrulline malate, would be more effective on older adults in the same way that younger adults aren't using Viagra.
Right. Yeah.
Now, you mentioned mechanistic overlap, and that's not mechanistic overlap, but mechanism is one of the things that I really wanted to talk to you about. So, in the philosophy of science, mechanism typically refers to the thesis, maybe that facts about chemistry or biology supervene on physical facts, on physics. So, chemistry and biology are just physics, really. But that's not, I think, the way that you use the term in exercise science. What I'm thinking of is something like the carbohydrate-insulin model of obesity, where you identify a mechanism that seems to plausibly contribute to some pathology or state, but then you really just hammer down on it as the cause and neglect other factors. Is that sort of one of the problems of I guess I didn't really say what mechanism is. You'd probably do a better job of that.
Yeah. So as a non-philosopher, I do expect I'll probably step into some linguistic traps here or use terms that are used completely differently in other fields. But now that I'm a professional fitness blogger and I wear sweatpants every day, you'll have to allow some linguistic missteps here. But in our world, where we talk about interpreting research related to health, wellness, fitness, and so on, there is a bit of a distinction between what we might consider very mechanistic research and what we might consider very applied research with high ecological validity. So, for example, one of the things I've been writing about over the last couple of days is linoleic acid, which is a polyunsaturated fatty acid. And there are all sorts of studies where people will look at it and say, based on the way this behaves in a petri dish, or based on the way this impacts a mouse who's being fed really absurd amounts of it, we can therefore conclude that a human being should definitely not be eating this or should be limiting it to the extent possible. So a lot of times there are people who will look at some of these mechanistic concepts. If we kind of boil down to very, very artificially created laboratory scenarios and see how something works, we say, okay, we'll just assume that is exactly how it works in the human body in a typical human diet, and we can extrapolate from there and solve all of our problems and understand how a human should eat. On the flip side, there are people who prefer to lean much more heavily on more applied research, looking at the actual outcomes of interest, looking at scenarios with a high level of ecological validity, things that really do seem to replicate typical everyday life. So I'm much more in the camp of, if I see some research, for example, looking at, okay, if we feed mice a very implausible level of linoleic acid and the following happens, we can use that to make very confident conclusions about the human diet, the optimal human diet, if we grant ourselves the small assumptions that humans and mice are functionally the same thing and that we fully understand every possible scenario that could possibly mediate or moderate these effects in the context of a human diet and human life. So usually we have to give ourselves the if we want to extrapolate from this highly mechanistic research that is very much removed from everyday life in a human being, we have to grant ourselves some very, very liberal latitude to make some assumptions that we almost never can truly justify if we're being rigorous and serious about our line of thinking. So there are kind of these two camps within our field, where some people are constantly working their way through mechanisms and saying, well, if we look at how this works in a petri dish, and let's just assume that the human body is going to be very similar to this petri dish and no other elements of human physiology are going to interact with any step of this, then we can make a conclusion. I'm much more inclined to say, well, you're telling me that linoleic acid is bad. You're telling me that it's toxic sometimes. What if we just looked at what happens when people eat a lot of it? It's like, what if we did that? And of course, that's an oversimplification. But when we have, of course, observational epidemiological nutrition evidence, when we have randomized controlled trials with controlled feeding, when we have longer term prospective studies with large cohorts, we have better information that we can use to make conclusions about how a human being ought to eat and what risk this particular dietary ingredient might have, what risk or benefit. And so, yeah, you often run into these scenarios where you'll see people saying, for example, linoleic acid is totally toxic because look at these mice. But then you'll return and say, well, this seems to be very clearly cardioprotective in human beings and reduces all-cause mortality when it's eaten in high levels. So yeah, I think that's kind of a roundabout answer, but there is a big there's a big gap in the discourse in our fitness related research world, where there are some folks who want to focus, like you said, on mechanistic ideas and theories like this carbohydrate-insulin model, and then other folks will come in and say, well, we've done a lot of randomized controlled trials, and if your model is right, then we should expect to see X. But when humans actually try to apply this theory, this mechanistic basis, and try to put that into an intervention, it just doesn't work. And so that's kind of the gap.
Mm-hmm. What is linoleic acid? What does it do?
Yeah, so it's an omega-6 polyunsaturated fatty acid. So it is an essential fatty acid that the body cannot make in sufficient quantities. So we do have to consume it in our diet, and it has many functions in the body. It's present in the membranes of cells. It's ubiquitous. It's just like omega-3 fatty acids will get incorporated into different cells and tissues and have various physiological functions. Omega-6 fatty acids are very similar in that sense. And so there has been a big there's been a big push to kind of vilify linoleic acid and omega-6 fatty acids because they are components of seed oils, which in our evolutionary history would have been pretty hard to come by a seed oil. With the processing required is just something that is newer, right? And so there's a big movement in nutrition that says, hey, things are going a bit awry in terms of human cardiometabolic health and adiposity at the population level, right? So obesity rates have been rising. The prevalence of cardiometabolic disease has been rising over the last several decades. And so people are very quick to say, we need to find the one dietary ingredient that is fueling that trend, right? And so we've gone through a lot of phases with that. Saturated fat, dietary cholesterol, sugar, carbohydrate in general, alluding to the model that you mentioned, the carbohydrate-insulin model. We're always kind of perpetually shuffling through and saying, if we just find the one dietary component or ingredient, then this will solve all of our problems. And I admire the folks who keep trying, but I think the more we look at it, we start to appreciate the complexity of obesity, adiposity, cardiometabolic disease rates. We start to see that it's much more complex than that. But basically, to answer your question, linoleic acid is an essential fatty acid that is just kind of the flavor of the month when it comes to finding a dietary component or nutrient to vilify. The idea there is that it is susceptible to lipid peroxidation and leads to a bunch of excess inflammation and causes all these sorts of issues. Sometimes people will throw in there the idea that it causes us to kind of passively overeat, which is very soundly rejected by human evidence, but it seems to be that way in mice, which again kind of instructs us that we need to be very, very cautious about extrapolating from non-human models when human models could be ethically and feasibly investigated. But yeah, so that's what it is, and it's just kind of the new thing. And like I said, I think it's it's an attractive or a very appealing option when we say, hey, humans are experiencing unprecedented cardiometabolic challenges when we compare it to our evolutionary history. What could be driving it? It's very appealing to say, well, what's new? What is a thing we eat now that we could not have eaten, 10,000 years ago, 5,000 years ago? And so seed oil certainly fit the bill. We were not going to be eating those in high quantities throughout the majority of our evolutionary history. And it kind of goes into the general line of thinking that we associate with like the Paleolithic diet, which is like, hey, things seem to be going fine back then, so let's just eat what we used to eat back then and hope for the best. But even that starts to lead into a lot of questions about, is it really all that feasible to suggest that you could eat that way based on not just the foods you choose, but the actual composition of those foods in the modern food environment? An apple today is not the same thing as an apple 15,000 years ago. And the same thing goes for a lot of the produce we consume and a lot of the animal products that people consume. So yeah, that's what it is.
Yeah. Okay. Well, I'd like to go back to the carbohydrate insulin model and maybe take it as use it as another example to show just where this sort of reasoning goes wrong, because it's personally important to me. I think I read Good Calories, Bad Calories in like 2011 or so. Did you ever read that book?
I did not.
Okay, so that's for people who don't know, it's a book by Gary Taubes, who's one of the major proponents of the carbohydrate insulin model, and I think still is a proponent of it the last I heard. And for I don't know how long, 7, 8 years, I was convinced by it. I thought the book, from an outsider's perspective, was extremely well argued and well written. I mean, he is a journalist and a smart guy, so he can write a good book. But for 7 or 8 years, I thought that carbohydrates were the devil, essentially. And I know you're a bodybuilder. The leanest I ever got was about 7%, according to a DEXA scan. I don't compete though, and that was eating tons of carbohydrate. So I mean, I eventually realized that I was totally wrong. And why I find this such an interesting case is that, on the one hand, as somebody who is kind of smart, at least, and thinks deeply, I was so convinced by this, and then found out, not just from listening to podcasts like yours or listening to Lane Norton or Iron Culture, that it was totally wrong, but experienced it as totally wrong. So maybe we could start, or you could start, since you'll do a better job than I am, by saying just what the carbohydrate insulin model is.
Yeah, well, you read the book, so you might be able to describe it even better than I could. I will admit it's one of the theories that I was aware of, and had looked over it. But even by the time I got interested in this stuff, I had seen enough that knowing the relevant literature, I saw the argument and I said, well, that doesn't work. So I never really got into that phase of my career where I felt like debunking it or drilling down into it really aggressively, because yeah, I mean, the general idea here, you've got these two rival camps or schools of thought, and there's the carbohydrate insulin model, which broadly proposes that people develop obesity, gain weight, gain fat, and ultimately develop cardiometabolic diseases because they are specifically overeating carbohydrate. And anyone with diabetes of any type obviously is very well aware that when we consume carbohydrate, they're in the time period immediately following that meal, blood glucose goes up, insulin is elevated to dispose of that blood glucose, and then everything falls back down to normal, right? So having consuming carbohydrate elicits an immediate insulin response that manages basically shuttling those carbs to where they need to go, and clearing them from the blood. So the idea is that, very broadly speaking, if you eat a lot of carbohydrate, you have all these, more insulin responses and larger insulin responses throughout the day. And when insulin is high, fat burning is suppressed. And it basically just kind of goes into this whole theory that the hormonal response to what we eat is driving obesity rather than the actual energy content of what we have eaten. And therefore, and I'm paraphrasing, I know that people who are really adamant about this theory are going to say, you totally mischaracterized it. Yes, I am.
I'm
because
not
I'm
holding
just,
you to that standard.
yeah, I'm not, I haven't really been, one of the reasons I haven't been really getting too deep into this particular theory or argument is because it seems to be changing over time. And I remember, I don't remember all the details, but there was a paper that came out, a big kind of collaborative review paper that came out within the last year or two. I know we talked about it on the Stronger by Science podcast, but basically a lot of the biggest proponents of the carbohydrate insulin model said, oh, no, you totally misunderstand what we were getting at. And then it seems like they're kind of trying to retrofit the model until it basically approximates the competing model, just say, which is basically a concession of like, yeah, this doesn't really work in the way we initially kind of formulated and shared it with the world. But ultimately, the idea there is that the hormonal response, and specifically the insulin response to the meals we eat, is what is actually driving weight gain and obesity as a causative factor. And therefore, if we can simply manipulate our diet to reduce those glucose excursions and the subsequent insulin responses, we should be able to achieve very passive, very easy weight management, weight maintenance, and avoid the progression of weight gain, obesity, cardiometabolic risk, and so on. And then, of course, the competing theory is usually abbreviated as calories in, calories out, or the energy balance model. And again, very superficial overview here. The idea is, hey, if you eat more energy than you're burning, laws of physics and thermodynamics do apply. That energy has to go somewhere. And if we consistently eat more energy than we are, or consume and absorb more energy from the diet than we're burning in terms of our daily activity and energy expenditure, if we're in this consistent surplus where the intake exceeds the expenditure, we're probably going to store it. And the best, easiest way for humans to store extra energy is by adding new fat tissue. And that model seems to work out. It's fully compatible with, like I said, pretty general accepted laws of physics and thermodynamics. When we have people in controlled conditions and we overfeed them, they gain weight in a way that is pretty easily explained. And then when we restrict energy, they lose that weight. And I think that one of the more one of the biggest hurdles that the carbohydrate insulin model really fails to clear is that we have controlled studies involving both underfeeding and overfeeding, and we can very, very clearly draw the line between energy intake and subsequent body composition responses. And the carbohydrate content, the things that should moderate insulin responses in a meaningful way, they just don't really seem to be very predictive of subsequent changes in body weight, body composition, or the progression of anything that we would really associate with cardiometabolic disease risk. So the energy balance model seems to work quite well in terms of explaining what happens in controlled feeding conditions. And the carbohydrate insulin model seems to really fall short when it's put to the test in controlled conditions. I think one of the things that muddies the waters a bit is that we need to branch out. So you asked me to describe what is exercise science. I think another very valid question is, what is nutrition? And it's not just biochemistry and bioenergetics. There is, nutrition involves human behavior, psychology, social factors, environmental factors. So one of the things that muddies the waters a bit is you'll hear from all sorts of folks who say, oh, I cut out carbs and I lost a bunch of weight, and I tried other diets and they didn't work. And on the surface, you'd say, oh, wow, looks like another win for the carbohydrate insulin model. But in reality, what we're seeing there is, in most cases, carbohydrate reduction for those individuals in their psychological context and social context and environmental context seems to be the most sustainable and feasible way to reduce their energy intake. And so it's, it's kind of a little easy, theoretically easy strategy to say, how can I reduce my energy intake and start losing weight? Well, if I don't eat carbs, I'm probably not going to be taking shots of olive oil to replace those calories. And so, yeah, for a lot of people, that does end up being a very feasible intervention, but it's not because insulin is, this root cause of obesity and things like that. It's because they found a feasible way to end up reducing their energy intake. And a lot of times people on the other side will say, I took this energy balance model seriously. I tried to really carefully watch my calorie intake, and it didn't work for me. And so that kind of works on the other end of people seemingly kind of losing faith in the energy balance model. But usually what's going on there is adherence is very difficult. And even if you are making an earnest effort to adhere to a calorie reduction diet, sometimes it can be just logistically very challenging to very accurately quantify your energy intake. And then there's just error associated with tracking. And then a third factor is energy expenditure is dynamic. And so almost 2 years ago, we released the MacroFactor diet app, which helps people track their calories, track their changes in body weight and body composition over time. And what it does is it provides an estimate of an individual's energy expenditure, based on the data inputs that are going in. And energy expenditure is pretty dynamic. So for example, if you decide I want to gain 30 pounds and you start eating really, really hard, you start really over consuming calories, your energy expenditure will go up in the process of that. And so what was allowing you to gain weight at a particular pace at the beginning of the process, you're going to have to eat more if you want to eventually maintain that pace of weight increase. And the opposite is true during weight loss. A lot of people will say, yeah, I reduced my calories to 2,200 a day. I was losing this many pounds per month. It was going great. And then it stopped, it stopped working. Usually what happens there is we see one of two things. There are adherence issues that start to come up as hunger becomes more pertinent, or just fatigue of trying to adhere to this diet for a long time. But another thing that can happen is a person's energy expenditure actually goes down. And so we have seen, just from talking to users in our online communities, a lot of folks who say, yeah, I used to always think that I was kind of a non-responder to diets because they would stop working after a while. But now I can see how much my energy expenditure actually tends to drop when I do a weight loss diet. And just from kind of seeing that visual feedback, it's a very reassuring thing that says, hey, physiology still works, physics still works, thermodynamics, it still works. But what we need to do is adapt to the physiological reality of energy expenditure dropping as we go. So those are kind of the two competing theories. And I want to be clear that I have no reservations, no issues with people adopting low carbohydrate diets, which would be the kind of intuitive conclusion of the carbohydrate insulin model would be, oh, you should go on a low carb diet or even a ketogenic diet. I mean, if you look at the app that we designed, I was kind of the person in charge of all the macronutrient allocations and the underlying logic there. We have a low carb option for users, and we even have a ketogenic option, which is very, very low carbohydrate. So I have zero issues with people who say, hey, I really like this approach to dieting and it works for me. I think that's great. I think the more we can help people find options that work for them, the better. But yeah, I think the underlying kind of mechanistic underpinning, this idea that we must go low carbohydrate for success because we need to really aggressively manipulate insulin responses, the empirical evidence just really isn't there.
And just to maybe sum up, my understanding is that it's not that the mechanism doesn't work. I mean, we know that eating carbohydrate raises blood glucose, raises insulin. You mentioned those things. It's that the body is just so complicated that you can't reduce it to one factor. Uh, there are other competing mechanisms that will interfere with the effect that you expect from reducing carbohydrate, that will prevent the sort of anticipated weight loss.
Yeah, yeah, and I mean that's kind of one of the overarching issues with folks in fitness, exercise, nutrition who will take a isolated mechanistic finding and extrapolate to an applied
Right,
outcome.
right.
Like I said, there are a number of assumptions that have to be leaned on in order to make that leap. And usually one of the assumptions that's never stated is if we just assume that we know every single thing that could possibly impact this chain of events, then what I say, my following conclusion should be correct. And we almost never have a full understanding of every single, I mean, if you look at like a little flow chart of like human energy metabolism, it's just massive, complex, overly complicated web of all these interacting factors. So yeah, the issue is not that, lowering carbs doesn't work. I mean, for some people, it's a very viable route to weight loss and fat loss. But the issue is trying to say that insulin is the single thing that needs to be modified in order to impact all these various outcomes. There's just too much complexity. And, sometimes, for example, people will say, oh, insulin is the fat storage hormone. Well, you can still store fat without the action of a large insulin response. So a lot of times it's just a great deal of oversimplification for things that are very, very complex. So I usually tell people the carbohydrate insulin model, based on the empirical research, particularly the research done in controlled feeding studies in humans, that the research just doesn't support the theory. But if you really prefer a low carb diet, that's a completely viable option for something that's ultimately very complex. There's a lot of complexity with human weight regulation, and if you can find a feasible intervention that gets you where you're trying to go, then that's what it's all about.
Mm-hmm. In my case, there's sort of a psychological motivation or predisposition to oversimplify things. So I recently interviewed this professor, Tanya Lombroso of Princeton, who runs a lab called the Concepts and Cognition Lab, where she largely researches explanation and the sorts of phenomena we find jump out at us as demanding explanation, or the sort of intuitions we have about what make good explanations. And in the case of the carbohydrate insulin model, if I immediately cut out carbohydrates from my diet, I might lose 10 pounds on the scale in 5 days. And if I haven't been eating carbs and I suddenly add them, I will see my scale weight jump up 10 pounds. And of course, you and I know that this is because of water retention. But most people aren't really, they don't have that knowledge just because they're not listening to Stronger by Science. And when we see this on the scale, we immediately jump to the oversimplified explanation. Oh, it's because I cut out carbohydrates, I lost 10 pounds of fat. And they aren't realizing the much more complicated situation, which is when you have less carbohydrate in your body, you are storing much less water.
Yeah, absolutely. I mean, it's water. It's also usually just bulk content of the GI tract as well.
Yeah.
I had a buddy who was running a body composition study, and someone came in and did their post test, and he says, "What in the world happened here?" And he's talking to the participants. So something's weird. And it turned out that the participant they did an eating competition 1 or 2 days before the final body composition assessment. So their GI tract was just full of bulk content from just engorging in a competitive sense. And so, a lot of times when we cut out carbs, we cut out a lot of the fiber content of our diet in some cases, which can, we will see some reductions in just the bulk content of the GI tract, in addition to the fact that we are probably storing less glycogen, primarily in our liver and muscle tissue. And the glycogen often leads to some degree of water retention as well. And some people even end up reducing their sodium intake a little bit, depending on their dietary preferences when they make a large change like that. So one of the things that I think you're very correct in pointing out is that the major advantage of these carbohydrate restricting diets is that they exploit some of these quirky little physiological things that induce a fairly rapid drop in body weight. And that's not fat loss, but it's still a drop in body weight. And we can't really tell. All we can do is look at the scale and say, whoa, I'm down 4 pounds already. Look at this. And so it does kind of lead into this, when you experience that intended outcome so rapidly, and it seems like, wow, that wasn't so hard at all. I think you are kind of primed and conditioned to say, okay, when I am able to effectively reduce carbs, I know that I have very rapid and very repeatable success. And therefore, even if I kind of lose interest in it and I regain the weight eventually and whatever, the next time I diet, I know that I should be doing low carb because I've already experienced the success once before. So I think that immediate kind of feedback that we get from scale weight with carbohydrate reduction definitely feeds in to a lot of the excitement about the carbohydrate insulin model and some of these low carb diet approaches. And like I said, it's if people like doing low carb diets, that's great. But it's very important to be equipped with that knowledge so that you don't fool yourself into thinking that something is going very differently than it truly is.
Right. And I think something key that you said there is when you're able to adhere to the low carbohydrate diet, because in my case, adherence was extremely difficult. So I would be on the diet for 5 or 10 days and I would lose 5 or 10 pounds. And then that is when I would stop adhering. So I wouldn't see the weight loss slow down or even slightly rebound. And then this morphed into an eating disorder where I would get so frustrated with myself that I would then end up binging. And then it would be this huge back and forth yo-yo diet.
Yeah. I think a lot of people hear about this kind of thing and say, well, that's harmless enough. What does it matter? But I do think that there are, you just described one very realistic potential consequence of that, of not kind of being, not being prepared to fully contextualize some of that scale feedback. But another thing that happens is people will experience that rapid reduction in body weight and say, this is working. And then even if they can adhere to it for a while, obviously that's a finite response. You're not going to lose 5 pounds every week of water weight. You lose your initial you have a little drop in water weight and bulk GI content, and then things kind of stabilize. What's really another potential downside of that is that some folks will see the diet, see that initially it worked and then it didn't, and they will internalize that as saying, I know that this works, but there's something wrong with me and I'm unable to I'm unable to sustain that success even with my best efforts. And that can become problematic because instead of then saying, oh, I tried a low carb diet, I lost some water weight, but I didn't really lose any fat along the way, I need to find a different approach that's just more compatible with my preferences and my lifestyle. Instead of doing that, people will get convinced from that initial drop in weight, this is the diet for me. The problem is I personally fail later on. And then as things start to slow down, I stop or I run into more challenges with adherence. I go off the diet, I regain the weight. And again, the noteworthy issue there is that the person has convinced themselves of two things, which is the low carb diet is the way for me to do this, but also number two, I tend to fail when I do the low carb diet eventually. So instead of looking for a more suitable solution that works better for them, they feel locked into the cycle of having identified the only thing that works for them, but then also understanding that eventually it stops working for them. And it's one of those things that just really detracts from an individual's self-efficacy. And instead of going out there and finding something that's a much better fit for them, they're locked into this kind of cyclical approach that ends up being not as fruitful as they would hope.
Yeah, and that was exactly my experience for 8 years or so. Now, before we move on, there are a lot of other things I want to get to, including the MacroFactor diet app. But I think this was a few years ago, and that I heard you tell this story. And before I ask you about it, I'll preface with why I think it's relevant. So I didn't know about the water weight, and this was just a case where a lack of education severely impaired my ability to diet properly or train properly or what have you. But you told this story, and I think it was about maybe a college roommate who you suggested get on like protein powder or something, but they ended up taking like mass gainer. Does that ring any bells?
So, okay. Yeah. So this was a story that Greg told,
Oh,
actually.
okay.
Yeah. So there was someone he knew in college who
Greg, your
wanted,
co-host.
correct. Yeah. And the individual wanted to get very lean very quickly for like a spring break trip or something like that. And Greg had explained to them the concept of what's known in the clinical nutrition literature as a protein sparing modified fast. And so usually what you're trying to do there is eat a lot of lean protein sources, low calorie, high protein. And it's a very, very low calorie diet, very extreme, but you try to get as much protein in as you can to try to preserve muscle mass. And so I believe his instruction was get some, white meat, kind of plain skinless chicken breast, and a bunch of whey protein isolate, which is just like a really purified protein powder that doesn't have a lot of carbohydrate or fat in it. And so those are your protein sources, and that's going to make up the majority of your diet. And there was a miscommunication, and the individual ended up getting a weight gainer protein shake, which is just loaded with as many carbs as they can possibly fit in there, and a bunch of extra fat as well. So it's an intentionally obscenely high calorie protein shake. Sometimes you'll see like 800 or 1,000 calories per serving in some of these products, if memory serves. And then he got like the fattiest chicken thighs with skin on that you could possibly get. And so, yeah, the person, and anyway, yeah, that was the preface. So you can take it over from there.
No, well, then I think he just got. I mean, I haven't heard it. Maybe you haven't heard it for a few years either. But then he ended up gaining a lot of weight, so he clearly didn't get that spring break bod he was hoping for.
Yeah, and yeah, yeah. He probably dramatically increased his calorie intake from making those substitutions, and was so surprised. He's like, "You told me this was going to get me very lean very quickly," and yeah, the devil's in the details with that.
Yeah, and then I guess another story, and again, maybe this was Greg. It's been a while. I think it was you, but the Dreamer bulk, the history behind what the Dreamer bulk is. So my Dreamer bulk, and everybody, I guess the joke is that everybody at some point in their weightlifting career goes on a Dreamer bulk, but mine I think was in like 2019. I was like 180 pounds maybe, which is what I am now. And I thought, okay, I'm just going to get so jacked. And I was eating probably like 8,000 calories a day, like getting burritos all the time. As soon as I got up, I would grab a fistful of cookies and cream, Hershey's fun size candy bars, and stuff as many down as I was going on a walk. And I got up to my like heaviest weight ever, which was north of 220 pounds, and I'm 5'10". And yeah, I put like 20 pounds on my squat, but it was all fat. Once I like lost that weight, it didn't help at all.
Yeah, yeah. I think, yeah, we had talked about that on our podcast, and I feel like most of the people that we know that have really achieved anything of note in terms of strength or, bodybuilding, physique, muscle building, almost everyone has done something like that exactly once in their
Yeah.
lifting journey. But I just can't fathom that it's actually an advisable thing to do. But it is one of those things where we keep saying like, this is so dumb, but we're like, yeah, but it is. Everyone we know has done it that has succeeded in these endeavors. I believe to be a completely a pure correlation rather than causation in that sense. But anyway, yeah, we've all been there, and I remember my first year in college, just putting on obscene amounts of weight and just eating. My first 2 years in college, I really gained a tremendous amount of weight, eating anything and everything available to me. And it was fun and, it worked. But it is kind of funny because I had deluded myself into thinking that it was almost all muscle. And, I'd see my scale weight going up and I did get a lot stronger.
Yeah.
But man, I remember thinking in the moment that it was all muscle. And then a roommate told me like, hey, I'm your friend, which involves telling you things that are hard to hear. And no one else is willing to tell you this, but you are gaining a tremendous amount of fat. And that's okay if that's what you want to do, but it's important that you know that.
Mm-hmm.
And so I've always appreciated his honesty because after
Mm-hmm.
he told me that, it was like all of a sudden something switched and I was like, oh yeah, I can see it now. and,
Mm-hmm.
and yeah, it was not necessarily advisable, not a particularly healthy phase of eating in my life, but it was fun. Had a good time. Did a lot of bench press. It went up. It was all good. But yeah, I think a lot of folks do that one time and then they start to realize, okay, I need to be a little bit more sensible in the way that I kind of adjust my calorie intake over time, because ultimately it becomes inefficient. If your goal is to gain 10 pounds of muscle but have the same body fat level, probably better to just take your time and gain the 10 pounds slowly rather than gaining 40 and then losing 30 and hoping that you end up in the same place.
Mm-hmm. So when we were talking about, I don't think it was the linoleic acid, I think it was the citrulline malate, you mentioned that your experiments were largely conducted on young, healthy adults. And I get the sense for like bodybuilders are always complaining about the populations that sports scientists are using. But in general, do the sorts of populations that you typically have access to in a sports science research setting negatively impact the reliability, maybe not the reliability of the research, but what you can extrapolate from it? Because I generally get the sense that you're limited to young sort of college age males that are willing to take like $20 to come into the lab.
Yeah, I think that there are, in some cases, hurdles with generalizability, which is basically, I studied this in a bunch of, 21-year-old college students, but this research question is mostly of interest to 65-year-old individuals with cardiometabolic risk factors, so trying to translate the finding from this group of individuals to this group of folks who are trying to apply it, it does lead to challenges. And it was really interesting in my program to see that different lab groups had different opportunities in terms of which populations they were sampling for their research. So, for example, we had folks who would do research on ACL reconstruction and kind of how that impacts movement. They really were locked in. They needed to find people who had ACL reconstructions. We did a study on individuals with who had recently undergone bariatric surgery, and again, you start getting into these really specific populations where you would it's just very, very clear that we can't just generalize from one group of research participants to a completely different population. Some of these populations are so specialized, and the research questions are so specific that you have to be really mindful of that. And that is one of the things that came up in my, as I was kind of reviewing the literature, explaining why we failed to find benefits pertaining to things like blood flow. If you look at older adults who might have some minor impairments in terms of cardiovascular function, endothelial function, these ingredients seem to work a lot better for people who have an underlying subclinical impairment. But yeah, the blood flow characteristics of a healthy, active 21-year-old are very different from that of someone who is, 59 years old and very sedentary, for example, or 68 years old and very sedentary, and especially as you start moving each decade from 40s to 50s to 60s to 70s to 80s, we start to see some really rapid changes in a variety of physiological functions. That's just the way aging works. And ultimately, I think that gets back to our conversation about mechanistic versus applied research. A lot of times when we talk about mechanisms or mechanistic research in our field, it really comes down to how something ought to work in a particular situation, right? So mechanistic research, a lot of fields might call it basic research. We're just looking at, in tightly controlled, sometimes very artificial situations, what does this thing actually do? How does it do it, within this context? And what does it mean? What ought it do if we apply that to a real world scenario? That's what a lot of the mechanistic research is looking at in the way we use the term. But applied research is like, well, does that actually pan out? Like when we start to actually try this in human beings who are doing that thing, and we're looking at that outcome that we said we were interested in, does this actually kind of work? And you have to keep the mechanisms in mind when you're doing this type of research, because yeah, without thinking through the mechanism, you'd say, well, I thought citrulline was going to enhance blood flow, or beetroot juice, and it didn't. What happened? You have to think through mechanistically and say, well, if it is correcting perhaps an underlying impairment of endothelial function, and we're looking at a sample of individuals who we should expect to have excellent endothelial function, perhaps when we kind of boil, so it's a bi-directional thing. When you're doing applied research, you kind of have to work backwards sometimes and say, well, okay, why does this make sense? The things that we just observed in a very applied setting with high ecological validity. So it's not, when I talk about mechanistic versus applied research, it's not that one is better or worse than the other. It's that we have to use each type of research for what it's actually intended for. So we should not be using totally mechanistic research with low ecological validity to make claims about very applied outcomes, without having a lot of other research kind of getting us there. At the same time, if we just had no understanding of how something worked in the body, and we were just saying, oh, it seems like if you take this, it makes you stronger, well, that's not enough. If for us to take that finding seriously, we have to actually understand how and why a particular ingredient is making somebody stronger. And so then we have to work backwards and say, okay, well, now it seems like we're observing this outcome, but we need to figure out why and how this is actually happening. So the two types of research are, they build upon one another, they support one another. It's this constant, you need all of it in order to have a cohesive understanding and a comprehensive understanding of how research is working. But yeah, the biggest issue is when people kind of misapply things, or they think only of applied outcomes without the mechanistic underpinning. Because like you said, when you're for someone like me, a lot of our research, if we're looking at how a particular supplement works, a lot of times we do have the latitude or the flexibility to bring in a convenient sample of college-aged folks, which is convenient because we're on a college campus. But if you're really digging into a very specific application and saying, we think this is going to be good for people who have congestive heart failure, you probably need to go out and find some folks with congestive heart failure to try to make that kind of claim.
Are there any ways in general, maybe with statistics or replication, that the field tries to deal or uses to deal with what I take to be the smaller or just otherwise limited sample sizes that you tend to get in exercise science? Because I get the sense that there's much less funding for exercise science than there is for like the medical school in general.
Yeah. Exercise science funding can be hard to come by. The most successful folks are, when it comes to securing funding, are the folks who can make a strong case that what they're researching is pertinent to public health or other elements that are important to society, right? So if you can say, I'm not doing this to see if bodybuilders can, add a half of an inch to the circumference of their biceps.
Which
I'm
is
doing
very
this.
important.
Yeah, you say the more effective researchers in terms of funding success are the ones who are saying, I'm studying muscle growth because muscle wasting is important in this medical condition, or we know with sarcopenia, individuals lose muscle over time. So funding is always a challenge, and the work that we do is just inherently, in many cases, very labor and resource intensive. So one of my colleagues at the Mass Research Review, Lauren Colenso Semple, she studies, really nitty gritty molecular stuff pertaining to muscle tissue, where they need to pull out muscle samples and do some pretty expensive and pretty invasive experiments. So, it's not quite as easy. Well, I don't want to use the term easy, but just in terms of the time investment per participant and the financial investment per participant, it's very different when you're looking at those types of experiments versus perhaps like an electronic survey study where you get a questionnaire out to, 500, 600, 700 people, and you can do that in a way that is logistically and economically feasible. For us, a lot of people like to criticize our field for small sample sizes, but I mean, there are real constraints that cannot be circumvented when it
Right.
comes to resources and just time investment. So, your question is, what do we do about it? So far, not much. And that I think is a very fair criticism of our field, is that, you asked me previously, what does an exercise scientist study? And I was like, well, I mean, we got to do physics, chemistry, biology, biochemistry, usually some element of education. If we're kind of branching out from physical education, we have to have a lot of anatomy and physiology knowledge. I took some pharmacology coursework. And then on top of all that, we usually, because we don't have a lot of money, we usually serve as our own statisticians. We don't have these we can't just throw a statistician on our grant and say, oh yeah, I'll carve out some money for that. The grants are too small. And so when you have to be the subject matter expert and the person literally collecting the data and analyze, you start to see that when you're wearing all these different hats, it can make it very unlikely that we're going to be seeing a lot of very sophisticated, very nuanced statistical modeling within our field. It's getting better. And one thing I am seeing that seems to be helping is, first of all, people are noticing that our stats need some overhauling, and that is happening. And second of all, I'm starting to see more multi-center trials, which is exactly what we need. So instead of
multi-center trial, I don't know what that is.
So instead of saying, I'm going to bring 20 people into my lab and answer this research question in its entirety, what you would say is, I'm going to collaborate with 6 of my colleagues, and we are all going to bring 20 participants into our laboratory and pool that data.
One laboratory or at multiple laboratories?
At multiple, so multi-site, multi-center. Okay. So each of these individuals, you could be running a trial at 4 or 5, 6 different universities where everyone, you get together, you make sure that your instrumentation is compatible, you make sure your methods are very, very clearly compatible and are being replicated effectively. And you basically are doing the same study at several places at once and trying to kind of be able to spread that workload and pool some resources together to make sure that you can actually have a large enough trial to make meaningful conclusions that are robust and rigorous. Because it's one of those things where I know a lot of researchers who say, yeah, I'm looking for an effect size this big if I'm being rigorous and honest with my expectations here. There's no way I could possibly get a sample size large enough to identify that effect and do everything effectively with the budgetary or resource-related constraints I currently face. And I think multi-center trials are going to help us team up and collaborate to get bigger sample sizes so we can address some of these issues more effectively. And then, of course, the two go hand in hand, because as you start doing multi-center trials, a t-test isn't going to cut it anymore. You need to start actually dealing with the clustering in your data. And so now you need to bring in some more nuanced statistical analysis. So I am seeing all the right things happening in the field. And I want to acknowledge that, like I said, I'm a professional blogger who wears sweatpants. So I don't take any credit. Like, I'm not saying, hey, we're doing better. I'm saying, hey, you're doing better. And I think that's fantastic. And I applaud that. So I don't want to make it seem like, oh, I'm not even part of that. I'm just a person who's been complaining about it for 5 or 10 years and now is starting to see some of that stuff occurring and is really happy about that.
Yeah, no, this multi-center trial idea is interesting to me. So granted, that seems to raise new budgetary issues, but two things that you didn't mention that it seems like this sort of model might address is one, issues of replication. So if you only have it at one site, it might not replicate. But if you have it at 6 sites, then it seems like you have a much you can have a much higher credence that it will replicate. And then one other issue. So when you mentioned that the sports scientist serves as the statistician, the subject matter expert, the experimenter, that seems like it could raise ethical concerns. If one person is overseeing all of this, then you really have to place a lot more trust in that person. And in every field, you have scientists who aren't ethical. But if you have 6 scientists running their own labs, then you can feel safer assuming that they all get somewhat similar data, that they're not all corrupt individuals.
Well, yeah, it'd be interesting if you do a trial at 6 different centers and one of them reports an effect size, a Cohen's D of 1.3, and everyone else comes up with 0, and you say, hey, what happened over at site number 6,
Yeah.
So I do think that it kind of alleviates those concerns. And I will say I oversimplified a little bit. So normally within a research team, these are small teams. It's going to be usually a professor and whatever grad student help they have. And so there will be measures taken to ensure just kind of the baseline best practices in science. So for example, when I say the one person is collecting the data, doing the analysis, all that stuff, there will be some degree of allocation of responsibilities to ensure things like blinding, for example, where you don't have literally one person who does the allocation and then does all of the measurements and then does the analysis. So usually you'll diversify those tasks a little bit among the small team you have to make sure that you can ensure in most cases, we try to do double-blinded studies to the extent possible in our field. So you will try to have some degree of just separating those tasks out enough to protect blinding. But generally, like I said, it's the people who are doing the stats in most of the studies in our field are not statisticians. They just aren't. They're subject matter experts who have been equipped with just enough of a statistical skill set to keep pace with what I would consider to be the bare minimum expectations within the field, which is usually in most cases a fairly straightforward application of kind of the basic toolkit of the general linear model. So t-test, ANOVA, correlation, and linear regression. And I know all the statisticians who are listening said, hey, everything you just explained is the same model. I know GLM, I get it. But that's usually the way that the statistical training works, is we'll learn the basic stuff. So different types of data, basic probability. And then I'll say, here's a t-test, here's ANOVA, here's correlation, here's regression. Try not to mess anything up too bad. And that's kind of how it goes.
One other problem, and I'm sorry for pounding these potential problems with sports science research on your head, that I imagine, for instance, somebody studying animals doesn't run into, is the problem that you might get when you have subjects who are already knowledgeable about the field. Maybe this is a hypothetical that you mentioned on the podcast, but you can change or give monkeys whatever sort of food you want. They can't really protest. They have to obey, or they have to obey. They have to eat what you give them if they're hungry. But if you want to study like different amounts of protein, how that affects muscle growth, and your participants are bodybuilders, you're going to have a real tough time giving one group of bodybuilders 50 grams of protein a day. They're just not going to do it. So you can't study it. Yeah. Does this replicate, I guess, or generalize to other studies that might be performed in sports science?
It's always something you have to keep in mind, where you have to say, so for example, with a protein study like that, perhaps one thing you would try to do is say, this isn't the best for ecological validity, but maybe the majority of your protein is coming from powders, and we can use a placebo powder so that the folks will say, oh, I don't know what's going in here, but we'll see at the end of the study, So double-blinded studies and the use of ethical and effective placebos usually play an important role there. There are some specific research questions where it's just very difficult to do blinding, and you do have to kind of
Yeah,
either
they're not going to
pick
cut down their volume to like zero.
right. You have to either pick your population very carefully or just brace for the fact that expectancy effects or other sources of kind of subject or participant level bias might be entering the mix a little bit. But you know, it is a challenging thing. And one of the other challenges related to that is aside from uh, people kind of knowing what to expect and trying to deal with that expectancy in studies that are not blinded. Kind of a related thing that you've alluded to is level of control. There are many instances where people will not cede a particular level of control to the research team. So, for
Right.
example, I did studies that if you study things related to bodybuilding, people will inevitably get fed up and say, stop doing this in college students, start studying bodybuilders if you're studying bodybuilding topics. And if you do that, that's great. But when you go to a bodybuilder and say, hey, you know how you've been training like crazy for this for a very, very long time and it means the world to you? Why don't you let me dictate what you're going to be doing the 6 weeks leading up to competition? I mean, the answer is going to be absolutely not, you know? So in many cases, I mean, trying to work with, trying to collaborate with sports teams, you know, high level athletics, it's very, very difficult to have any level of control over what they might be doing. So the idea of doing an experimental manipulation is almost always off the table. You have to rely on usually observational types of studies when you're working with high level athletes, because they will not let you control their training. There's too much at stake to them. And even then, some sports organizations are so protective of any edge they can get over the competition, they won't even let you observe what they're doing. You know, they won't even tell you what goes into the secret sauce of how they prepare for competition. So there's always this kind of this constant tug of war or battle going on where people are saying we need more research in these really specialized high level athletes, and then the other folks saying I'm trying, but they won't let me control anything they do, so I can't do an experiment, or they won't even let me know what they're doing, so I can't do observational work in this population. So it's really challenging.
One other sort of concern that comes to mind involves performance enhancing drugs. So I don't think people realize, like your average gym goer, I don't think they realize what percentage of people, if you go to a Planet Fitness or an LA Fitness, the amount of people that are taking performance enhancing drugs. So there are people taking at your local gym drugs that are made for breast cancer patients or for horses. And I imagine that even though studying that would be very important for public health, you can't run trials at the University of North Carolina where you're testing horse drugs on college students.
Yeah, I mean it's yeah, it's tough because I mean I do natural bodybuilding where
Right.
there's no drug use, and so when I was doing a lot of one-on-one coaching, I would restrict my coaching to natural competitors, and even when I was making content, I would often either explicitly or implicitly say, hey, by the way, this content really only applies to natural bodybuilding because, you know, for example, if I'm talking about how sex hormones change during dieting, a lot of times we'll see reductions in sex hormones when you get really lean and start under eating chronically. It's like, I can't even begin to generalize this to someone who's using exogenous sex hormones, you know, especially, you know, high levels of anabolic, you know, androgenic steroids, because first of all, I mean, there's minimal research on it. And second of all, there's virtually no research in this particular context. And, you know, so it does get tricky when you start adding that into the mix because no one really knows what anyone else is on. And even if you wanted to give evidence-based guidelines, there's just not an underlying base of evidence that is solid enough to really try to get into all that stuff in your content or your coaching or whatever. I mean, for me, it's the drug use stuff. Like I've even had situations where, you know, I've seen situations where even if you do have the good fortune of collaborating with a sports team who allows you a high level of access, you publish the research and someone say, they're probably all on steroids anyway, you know? And so it always kind of, there's this kind of cloud that hangs over exercise science, where in some cases you got people saying, oh, I think all those folks were on steroids. And then there are other folks who are saying, hey, I'm on steroids. How does this apply to me? It's just one of those things that is so, no one really talks about it. And so a lot of the folks who are trying to get like the best possible evidence, or, evidence-based recommendations pertaining to anything steroid related, it's really like, for lack of a better, I mean, there's a couple studies with doses that get into ranges that people might use for competitive purposes, but it really is kind of just like an oral tradition that gets passed down from,
Yeah.
My steroid guy told me this, and his steroid guy told him that, and it is one of those things where it is, it's kind of like the Wild West, where there's these folks who are making new compounds, people who are experimenting with them. It's a strange world, and I can't even remember what question you asked, but the answer is, do steroids complicate everything? The answer is yes, because no one knows what anyone's on, and even if we did, we don't have any real strong research by which to contextualize, what we're seeing.
I think the question I asked was, well, I don't know if it was a question, but I was raising the point that it would be very important or useful for public health to run studies on steroids, people taking performance enhancing drugs, but you just can't do it because it's not ethical. But
Yeah.
The next question, though, that I had before we get into MacroFactor, which I really want to talk a lot more about, is, are there more general ethical concerns that sports scientists have to keep in mind when they're designing experiments or appearing before IRBs that might not be endemic to other areas of science?
Yeah. So first, let me clarify, now that you restated the question with the steroid stuff. There are people who do public health research on steroid use. It's just very limited. We have to go off of self-reported histories of steroid use and there's a lot of case studies, for example, where you can say, okay, tell me all about what you did the last 10 years. And then we can kind of figure out how that might be contributing to the cardiac issue that we're treating you for. So there's a lot of case studies. There's a lot of anonymous survey data, forms of evidence. It would be a lot more informative to have randomized controlled trials. But like you said, those are few and far between. There are a couple. I mean, more than a couple. There's a small number of studies that use, there's a researcher with the last name Basine who did some studies where they did actual varying doses of anabolics. We can even, and there's some clinical applications where people use exogenous anabolics, and we can kind of make some inferences there. But usually the dosing and the types of compounds being used are just not even close to what people are using on the cutting edge these days. So we have to rely on other forms of evidence. In terms of ethical constraints in the sports science literature or the exercise science literature, I think it's fairly standard when comparing to other biomedical human subjects research. And then when you factor in the fact that there's often questionnaires, we kind of end up leaning on the same ethical constraints you might see with some of the social sciences in terms of privacy and things of that nature, deception, things like that. I don't think that our field has all that many unique ethical hurdles we have to jump over. But I do think one thing that's funny is I have seen I've seen a lot of variety in IRB applications within our field, because like I said, some folks are at universities that don't do a lot of biomedical research, and they're kind of housed in the College of Education. And I've seen some IRB ethics applications that are very, very minimal in our field, and I've like looked at them and said, where's the rest? And it's just very simple. But I've also been in departments where we go through the same, at the larger universities, there's different kind of sections of the IRB, and we go through the one that's like pure medical research. And I remember going through all sorts of hurdles where I had to I had to aggressively justify the safety of Crystal Light, just like a flavored beverage that's in your grocery store. I
Uh-huh.
had to defend the merits of using analysis of variance as a valid statistical technique. And so, yeah, I mean, I've seen all sorts of stuff like that, but I don't think it's particularly unique to our field. I think it's just the biggest thing is what kind of department are you in, and that's going to dictate what kind of hoops you jump through ethically. But yeah, the only other thing that I can think of that is a bit unique for us is we have to be extra sensitive about just from my area of research about body composition assessment. We need to make sure that participants are very well informed. For example, if you're doing skin fold analysis for body composition, like, hey, I am going to be pinching the subcutaneous fat layer, not hard, but it's going to be something that makes a lot of people feel very uncomfortable, very self-conscious. A lot of body composition assessments we'll have to say, you're going to essentially be wearing like a bathing suit in terms of the type of attire that you're wearing during this assessment. So there are some of those things that we have to be extra mindful of, is just making sure that participants are informed of what these assessments involve and making sure that they're comfortable with that, because we don't want to surprise anyone with a situation that's going to make them feel uncomfortable, embarrassed, self-conscious, anything like that.
Okay, so without any further ado, we can turn to MacroFactor. And disclosure to my listeners, I don't use MacroFactor, but I 100% would. I really trust you. I really trust Greg. Some of the other people I really trust, Eric Helms and Omar Isif, but they don't have a diet app.
Yeah.
But I 100% would use MacroFactor. And when people, I mean, since I'm like the fit, strong friend, people are always asking me how to track their macros, things like that. And I do that myself because I like tweaking things and I have fun with it. But I tell them, you don't want to do this. Trust me. Look at MacroFactor if you want to check out an app. But because I do that, I want to talk more about it, and I want to learn more about it. So you didn't ask me to talk about this, so this isn't an advertisement. I'm generally curious. So maybe though, for my philosopher listeners who you might be surprised, maybe you wouldn't be, but a lot of philosophy people are very interested in fitness and health. They're working out a lot, but they don't do a lot of research on this sort of stuff. So what
Yeah.
generally are macros, and why do we want to track them?
Yeah, I'm really not surprised by that, because I think the overlapping interest of philosophers and fitness. I remember back in the day, everyone who was really interested in fitness and wanted to seem very learned and sophisticated I think they would all post a quote from Socrates, I think, about perfecting the physical form or something like that.
Okay.
Um, I might be wrong about that, but anyway, there was some philosopher who had a quote about that was very pertinent to building one's body and physical capability. But anyway, yeah. So macros, right? So when we're eating food is energy, and we can break down the content of food based into these categories of what we call macronutrients. So we've got carbohydrate, protein, and fat. Carbohydrate and protein, on average, contributes about 4 calories per gram. So if you have 2 grams of carbs, it's going to be about 8 calories. And then fat is actually 9 calories per gram. So 2 grams of fat is going to be 18 calories that are coming into the diet. And then alcohol, you could factor that in as the kind of the 4th macronutrient there, which is usually about 7 calories per gram. So if we look at the content of a food or a meal that we consume, we can look at its composition in terms of its carb, fat, protein, and alcohol content. And we can also look at the fiber content as well. And we can get an idea of, when I ingest this food, how many calories am I introducing into the system that is my body. And so every day we have calorie intake and we have calorie expenditure. So just sitting around, our body is doing energy intensive processes that keep us alive and functioning. That's why we have to eat. Our body churns through energy. You need gas for a car. You need to charge batteries for your devices, and humans need to eat. We need that energy. And so the reason that we would look at calorie intake is so that we can make sure that we are kind of appropriately matching our intake and our expenditure for whatever our goals happen to be. So if someone wants to lose weight, they would want to make sure that their expenditure is pretty consistently greater than their energy intake. The opposite is true for someone who wants to gain weight. And then if someone just wants to maintain weight, what we're trying to do is establish a bit of an equilibrium there in the long run. Doesn't mean every single day you have to be right on the money, but we're talking about cumulative effects over time of how energy intake and expenditure kind of are balanced back and forth. The reason that we would look at macronutrient content, aside from the fact that, we can use that to figure out the caloric value of a food or a meal, is that these different nutrients play different roles in the body, right? So we talked about the energy balance theory, or we talked about carb-insulin model versus the energy balance model. And a common kind of straw man argument to detract from the energy balance model is like, so you're telling me that 100 grams of raw, pure sugar is the same thing as, the same number of calories of steak. And literally no one is telling you that that supports the energy balance model. We fully understand that these different macronutrients are going to play different roles in the body. We need essential fatty acids. We need essential amino acids. Proteins are going to play a different role in the body than carbohydrate or fat. So that's why we break things down a little further. We don't just say, hey, eat 2,000 calories today, because 2,000 calories with 200 grams of protein looks very different from 2,000 calories with 20 grams of protein. Those are substantively, majorly different diets in terms of how they're going to support your health, your body composition, strength, muscularity, etc. So we try to break things down into macronutrients so that we can have a little bit more control over exactly how is your body going to be responding to this diet. Because calories alone, while it helps us understand our energy balance, it doesn't tell us the full story of exactly how a particular diet is going to impact somebody's health, body composition, performance, and so on.
Okay. So then how does the app specifically work? So I would, if I downloaded it, I would input my weight naturally. Mm-hmm. What other things would I say? I suppose I would probably tell you my body weight goal, maybe my level of activity, but what sorts of other inputs does the app take?
Yeah. So when a person just is like just getting started, we'll do a little onboarding sequence where we gather enough information to estimate baseline total daily energy expenditure, right? So basic demographic information will ask you things about your height and weight, estimated body fat percentage or body composition. We'll kind of run through some really basic stuff so that we have enough information to use we'll ask you about your activity level, physical activity, exercise, etc. We'll ask you enough questions to get an idea so that we can use a validated equation to estimate your total daily energy expenditure. And for us, that serves as a starting point, because we're also going to ask you, well, what is your goal here? What are you trying to do? And we frame that goal in terms of changes in body weight or body mass. So people might be using the app because they want to stay relatively weight stable as they pursue an athletic goal. So as far as the app is concerned, the goal is weight stability, and that is facilitating whatever athletic goal. For example, there's some sports where athletes tend to lose weight over the course of the season. Maybe they don't want to do that. Maybe they want to make sure they're eating enough to maintain weight. The most common use cases of our app would be people who either just have no idea what they're eating and want to keep tabs on it just to have the information, or people who are specifically trying to gain or lose weight. Or I guess another application of that would be people who have lost a bunch of weight and they really want to be diligent about maintaining all the weight loss that they've achieved. So we'll ask you enough information to estimate your kind of starting energy expenditure level, ask you your goal about, do you want to gain weight, lose weight, maintain weight? If so, how quickly do you want to gain or lose weight? So we frame it as the rate of weight gain or weight loss rather than just I want to lose 20 pounds. It's more like I want to lose half a pound a week, for example. So that gives us enough information. Then, we'll ask about your food preferences. Do you like high carb diets, low carb diets, etc.? So we have this kind of onboarding sequence that goes pretty quickly, but gathers a lot of information so that we can provide kind of a starting point of recommendations. So, based on where you're at and where you're trying to go, we think you probably want to be consuming this many calories a day, this much carbohydrate, this much fat, this much protein. And that is where things start to get really interesting. And I should preface, I'm talking about the kind of coached mode here, which is what most people use, where the app is kind of coaching you along the way. There are other modes of operation where you can just set your own targets for everything, so there's different layers of customization. But with the coach programs, once we get the baseline stuff up and rolling, that's where the interesting stuff really begins, because every day you're going to be tracking your food intake, food and beverage intake. And one of the biggest priorities was to make our food logging experience as efficient as possible. And our developers, Corey and Rebecca, are magicians. I think that they've created the most efficient, most seamless food logging workflows that I could possibly imagine. And so we try to make it the ease of use be a really high priority. So as a user is using the app, they're going to be weighing themselves every day, tracking their body weight over time, tracking their nutritional intakes over time. And what we can do is we boil in a few assumptions here to facilitate calculations. But if we know how your body weight and by extension body composition is responding to a particular energy intake over time, if we apply some smoothing functions to your weight trend to make sure that we're not responding to noise rather than signal, we can triangulate the information about your trends in body weight and your trends in energy intake. And we can determine if you are actually eating the right amount of energy to be on track with your goal. We can kind of back calculate based on changes in body weight and composition, based on trends in energy intake. We can kind of back calculate what your energy expenditure ought to be by using some assumptions about the energy density of different body tissues. And so we have this kind of running estimate of your daily energy expenditure that we can use in conjunction with all the other data to refine your targets over time. So for example, someone, based on the initial preliminary estimate, we think, oh, you should be losing weight at the intended rate with 1900 calories per day. Well, over time, we're going to see what happens when you're eating 1900 calories per day. And we're going to see if it's too much, too little, based on your rate of weight change. And those targets for calories, carbs, fats, protein, those are going to change over time to get you on track and keep you on track with your intended goal, whether it's gaining, losing, or maintaining weight. And so someone might say, well, you're overcomplicating things, right? Because if all you want to know is, is weight loss happening quick enough or not, is it happening too fast, too slow, or just right? You don't really need all that expenditure stuff. But to me, that's the most important part of the app, is the fact that, that logic becomes very simple if we assume that you are always eating exactly what we told you to eat, right? So we could just say, okay,
Right.
we told you to eat 1900 calories. Let's assume that you always do every single day, no matter what. And then if, weight isn't dropping fast enough, then we'll just drop it to 1800, right? That would be simple enough. But the reason that we go through the process of thinking about things like tissue energy density, triangulating all this information to estimate expenditure, is because our app functions in a way that we call adherence neutral, which basically means our app continues to refine your estimates, even if you're not adhering to the targets for nutrition intake and for energy intake. The app can still use all the information that you're putting in to continue refining and triangulating your appropriate target. So whether or not you're perfectly adhering to the targets, we can continue to keep every single day that data is being entered, we're refining our understanding of how many calories you really need to get on track with the goal that you set. And so for a lot of people, that's had two consequences. First of all, it's way less stressful when this app is going to continue working even if I slip up a little bit, even if I deviate a little bit. A lot of people find that to be really reassuring. But one of the things that is really fascinating to me from a psychological perspective is some folks said, oh, you made this adherence neutral algorithm that continues providing refined and updated targets, even if a person is deviating from the plan. People have suggested that is going to cause people to be, there's less of an incentive to actually hit your target. So people have said, well, that's going to make it such that people don't adhere to their diet and then they never meet their goal. We have found the exact opposite to be true, which is we find that because people understand that the algorithm is continuously updating its targets and its understanding of their body day by day with entered information, people have told us that they are logging their weight and their nutrition intakes more consistently and more accurately than they ever have before, because they feel like instead of being told you have to eat 1900 calories, the app is saying probably be good if you ate 1900 calories, but let's see what you do and let's see how it goes. And so people feel like they are feeding data into an algorithm that is actually responding to what they did, rather than an app saying eat 1900 calories, and if you don't, leave me alone because you're not doing what it takes and I'm not going to update a damn thing. So it's been really interesting to see how, paradoxically, making it an adherence neutral algorithm, for us, it was the only way that made sense, because we've coached people. We know that adherence is not a perfectly stable thing that's going to be perfect all the time. But paradoxically, people have said, oh, that's going to remove all the incentive to use the app with a high level of accuracy and consistency. In fact, it's been completely the opposite.
No, that all sounds terrific. And now, in the interest of time, though, I have one last question, and maybe at some point we can talk more about MacroFactor, or I'll talk to Greg about MacroFactor. But right now, I'm just curious if there are any sort of bells and whistles that take into account current, or I guess more subtle or minute contributions in the sports science research. So like meal timing, intra-workout nutrition, protein quality. Are any of these sorts of things integrated into the app?
So the app is very data heavy. Okay. So the fine line that we want to straddle is we want to make sure that the insights and the analytics are available to the people who wish to use them, but we don't want it to be this overwhelming experience where, you get slapped on the wrist if we said, oh no, you had too much methionine and not enough lysine today, because we looked into your amino acid profiles of all your protein sources. So we want it to be comprehensive and absolutely packed with insights, but we don't want it to be overwhelming in terms of the actual recommendations. So in terms of meal timing, our app is totally compatible with any variety of time restricted eating protocols, intermittent fasting protocols. So if you leave a day blank, we ask you, okay, did you do a fasting day, or did you, forget to log your intakes that day? Because the algorithm is going to treat those two things very differently. So for people who are interested in meal timing, our food log is actually is in the form of a timeline. It's not just, oh, what'd you have for breakfast or dinner, like putting it into buckets. It's at 7 a.m. I ate this, and at 11 a.m. I ate that. So you can get all the insights you would want looking back at your food timeline. As long as the information has been provided by the food, whoever produced the food, you could track specific amino acid intakes and fatty acid intakes. So like you talked about protein quality, an individual would be able to look back and say, oh, wow, I was really low on lysine today. Now, I haven't talked to many people who use that level of insight with their looking through it, but there are some applications where that might be useful. So in terms of the bells and whistles, the insights are absolutely packed when it comes to those types of things. I think there's a couple other specific elements you mentioned, but the two that I remember are meal timing and protein quality. But yeah, I mean the analytics in there, the insights that you can draw out from the data that are tracked they're very, very in depth and very immense. And so we try to make sure that users can access all of that without being forced into an extremely overwhelming experience where the provided recommendations are getting into really nitty gritty, oh, you ate your dinner 5 minutes late, therefore you got to start over. We don't want to encourage those types of really, we would call that, whenever we see apps that are giving extremely cumbersome recommendations about timing and food sources, you can argue, based on the psychology literature, that falls under the umbrella of rigid cognitive restraint, where people are kind of locked into this idea it has to be perfect with timing and food choice and all that stuff. We absolutely, the app is characterized by our decision to embrace flexible cognitive restraint, which is let's focus on the big picture, provide all the data that you'd want for insights, and make sure that we're not. One of the reasons we call it MacroFactor, it's kind of a double meaning. So MacroFactor, of course, macros, short for macronutrients. But it's also a kind of a subtle reminder to focus on the macro factors rather than the micro factors. So focus on the big picture stuff rather than getting too bogged down in chasing perfection or these ultra minute details.
Right. Yeah. I mean, that's something a friend of mine today who's not in terrific shape is surfing regularly now. And he asked me how he could start like doing plyometrics to improve his like surfing ability, and I told him, that's like very advanced. Maybe focus on your GPP for now. So
right, yeah,
I see the consideration there. So anyway, Eric, this was the best possible introduction to sports science and some of the more relevant philosophical considerations there that I could have hoped for. So thanks so much for talking to me.
Yeah, thanks for having me. I really enjoyed it.
Hold on, Geeslings. Before you go, please like, subscribe, follow if you haven't already. Smash all those buttons. And also, if you haven't followed me on Twitter at Robinson Earhart, or if you're not joining me every morning as I eat my pint of ice cream on Twitch at Robinson Earhart on Robinson Eats, please do so.